This is a sarcomere, which is a segment of a myofibril that makes up striated muscle fibers. And the thick blue line here is a thick filament in the sarcomere, and the gray line is the actin, which is the thin filament in the sarcomere. The A band, which is this blue line up here, is the middle area in the sarcomere where thin and thick filaments are found. And the I band, which is on the outside, is the space containing the Z line and only actin, so there's no thick filament there. And the Z line is the actin borders that separate and link the sarcomeres. The H zone is the middle region of a sarcomere that contains only thick myosin filaments. And the M line is the very center of a sarcomere and is made up of miyomycin. And miyomycin is an end-line protein that makes up the M line, and its main job is to stabilize and align the structure of the sarcomere. Up here is dystrophin, and dystrophin connects the actin to the cellular membrane, so without it the sarcomeres wouldn't connect to the muscle fibers, so the sarcomeres would move, but the muscle fibers wouldn't. Eventually the sarcomeres would wear themselves out and wouldn't function anymore. And dystrophin is like the gears on a bicycle, so without it you're moving the pedals, which would be the sarcomeres, but the wheels, which are the muscle fibers, still wouldn't be moving. This is caused by an error in genetic coding, and it's what causes muscular dystrophy. Zoomed in 3D model of the myosin interacting with actin in the sarcomere, and just going through, this is ATP, which binds to ATPase and moves myosin to a high energy state. Here are calcium ions, which calcium causes the cross bridge to go down, which causes the muscle contraction, and calcium is stored in the terminal cisternae, which is a bulged area in the sarcoplasmic reticulum that only holds calcium. And the calcium binding site is actually on troponin, which are the blue marshmallows. And troponin is a protein of muscle tissue that when it binds with calcium ions, it changes shape. And the tropomyosin, which is the yellow pipe cleaner, in a relaxed muscle, tropomyosin blocks the attachment site for the myosin cross bridge, thus preventing contraction. But once troponin binds with calcium ions and changes shape, the tropomyosin moves to reveal the attachment site for the myosin cross bridge. So moving down, here is the thick filament myosin, and here's the myosin head, which inside the myosin head is the ATP binding site, which is ATPase, and ATPase is the enzyme that hydrolyzes ATP into ADP and a phosphate. So moving on to the actual contraction, first calcium ions will bind with the troponin, which causes the troponin to change shape, and for the sake of the video I'm just going to move it off, which then causes the tropomyosin to move to show the attachment sites for the myosin head. So first the myosin head starts off in a relaxed state, and then ATP binds with the ATPase, which then becomes hydrolyzed to be ADP and phosphate, which causes the myosin head to cock back. And then the phosphate falls off, which causes a cross bridge, which is where the myosin head actually binds with the attachment site. And then whenever the ADP falls off, that causes the power stroke, which causes the myosin head to actually move the whole line of actin down. And then whenever a new ATP binds with ATPase and turns into ADP and phosphorus, it recocks or goes back to, or what's called recovery phase, so then it can do the whole thing over again and attach and move it on.